Welcome to Discrete Mathematics-1 course. This is the course that I offer at Bronx Community College of the City University of New York. CSI30 Discrete Mathematics-1. The textbook used is Discrete Mathematics and its Applications, 7th edition, Rosen. Alright. So here is a syllabus. Here is the syllabus. Chapter 1, sections 1.1 until 1.6. Chapter 2, sections 2.1, 2.2, 2.3, and 2.6. Chapter 3, section 3.1. Chapter 4, sections 4.1, 4.2, 4.3, 4.5. Chapter 6, sections 6.1, 6.3, 6.4. Chapter 7, section 7.1. So this is the first part of Discrete Mathematics course. All right. Lesson 1. Propositional logic. A network primer. Rules of logic give precise meaning to mathematical statements. In addition, logic has numerous applications to computer science. These rules are used in the design of computer circuits, construction of computer programs, verification of the correctness of programs, and several other ways. What is a proposition? A proposition is a declarative sentence. That is, it's a sentence that declares a fact. In other words, it has to be either true or false, but not both. And it should not be vague or ambiguous. So a declarative sentence is a sentence that is either true or false. For example, 2 plus 2 equals 4. That's a declarative sentence. It is true in this case. Another sentence, 3 times 5 is 10. This is a false sentence. It is false. Yet, it is a proposition. It's a declarative sentence. New York is the capital of USA. This is also false. But this is a proposition. So these are examples of propositions. Could be true, could be false, but a declarative sentence, that is a sentence that declares a fact. What are non-examples? Here is a question. What is your name? This does not have any truth value. So this is not a proposition. Here is a request. Please write down. That's not a declarative sentence. X plus 1 equals 3. Well, if x is 2, this is true. If x is 10, this is false. So this sentence could be both true and false. So this is a non-example. Okay, so these are non-examples. All right. A variable that represents a proposition is called a propositional variable or statement variable. So you may as well say P is the statement 2 plus 2 equals 4. All right. Q is the proposition 3 times 5 is 10. Okay. So P is true, Q is false. That's okay. So these variables are called propositional variables or statement variables. Conventional letters used for propositional variables are P, Q, R, S, and so on. The truth value of a proposition is true, T, or false, F. The area of logic that deals with propositions is called propositional calculus or propositional logic. Propositional logic was first developed systematically by the Greek philosopher Aristotle. Compound propositions or new propositions are formed from existing propositions using logical operators. Okay? So, you use existing propositions and then operators on them. That's what creates compound propositions. What is negation? So this is an operation. Negation is one of the operations. It is a unary operation, that is, it takes only one argument. Let P be a proposition. The negation of P is denoted by not P or P bar. It is the statement, it is not the case that P. Alright? P is already a propositional, it is a proposition. P is already a proposition, so it's already a sentence. So it is not the case that P. That's what not P or P bar represents. The proposition not P is read not P. The truth value of not P is the opposite of that of P. So if P is true, not P is false. If P is false, not P is true. Find the negation of the proposition that television is on. The negation of this sentence or this proposition is, it is not the case that the television is on. Okay? That's how you state it. It is not the case that the television is on. Well, we know what that means. It means the television is off. Find the negation of the proposition. I have at least $3,000 in my bank account. What's the negation of that? It is not the case that, so it is not the case that I have at least $3,000 in my bank account. What's the opposite of at least? It is less than. So when you say it is not the case that I have at least $3,000 in my bank account, what you're actually telling me is that I have less than $3,000 in my bank account. Okay? Next, here is the truth table for the negation operator. Notice, negation operator is a unary operator. So if a proposition is here, not P is written here. Proposition is true, not P is false. Proposition is, if the proposition P is false, not P is true. Logical operators that are used to form new propositions from two or more existing propositions are called connectives. Connectives, they connect two or more propositions.